So, good day, class. I hope that you are doing well today. I am Teacher Regine, and today we are going to talk about the Earth's changing climate. But before we start with our topic for today, let's have a quick review on our previous lesson, which is all about the global climate. So, we learn now that global climate refers to the long-term patterns of temperature, wind, humidity, and rainfall across the earth. So, it's not a daily weather, no, rather it's the big picture over many years. Then we also talk about what affects climate, like the sun's energy, greenhouse gases, ocean currents, and even the Earth's shape and tilt. Now that we understand how climate works naturally, today we will focus on something more urgent, no? How and why Earth's climate is changing faster than ever before. So today we are going to explore a topic that both scientific and deeply connected to our daily lives. The Earth's changing climate. So at the end of this lesson, no, you will have a better understanding of how Earth's climate has changed over time, why it is happening faster today, and what it means for us and the planet. So here are our goals, no, for today. By the end of this lesson, you should be able to describe how Earth's climate has changed throughout the history, then identify both natural and human-made causes of climate change, then explain why climate change matters in the past and today. Then understand the causes and effects of global warming and how people are working to reduce it. So the Earth's climate has never been constant. So it's always been changing, sometimes slowly and other times more quickly. Now, let's go back for about 18,000 years ago during the peak of the last ice age. So back then, sea levels were much lower, so low, that land actually connected areas that are now separated by water. So, for example, is the English Channel, which today now separates England from mainland Europe, which did not exist yet because it was all dry land. And there was also something called the Bering Land Bridge, which connected Siberia to Alaska, which allowed early humans and animals to migrate from Asia to North America on foot. So can you imagine that? So you can see also in these two maps below, these white areas there represents the glaciers that covered a large part of the northern continents. Then you will also notice more land exposed, because the sea level was lower. Now, look at the graph, in the top right corner. So this shows us how temperature has changed over the past 20,000 years. So on the horizontal axis, we have time going from 18,000 years ago on the left and today on the right. Then on the vertical axis, we have temperature, which is lower at the bottom and warmer at the top. Then you'll notice that the red line represents how temperature has changed. So for around 18,000 years ago, temperature were much colder. And as time moved forward, the climate gradually warmed. So there were some sudden shifts, like during the Younger Dryas period, which was a short return to colder conditions. Then after that, warming continued into the Holocene maximum, which is a warmer period. Then today we are at the far right, no, where the temperature is rising again, but this time much faster than in the past. No, so there are two things, no, on what this means. So first is climate change is natural because the earth has warm and cold so many times. Then second one is that today's climate change is happening much faster than before. And that's what we will explore more now in this lesson. So this illustration shows that if happens that all the ice on earth melts, it shows that Florida is in danger because sea levels would rise for about 65 meters or 210 feet. Then the highest point in Florida is only 345 feet above sea level. So that means that almost all of Florida, including the cities, homes, and beaches, would be underwater except for the high spots. This is because Florida is very flat and close to sea level. Now, take a look at this image. It shows ocean surface temperature from 18,000 years ago and today. So as you can see, the red for warm areas for around 25 degrees Celsius or higher, and blue for cool areas for around 10 degrees Celsius or lower. So as what we observed, it clearly shows that warm ocean areas have grown larger and cool areas smaller. So this means that the oceans have warmed significantly since the last ice age, reflecting major changes in Earth's climate. So now let's determine the past climates. So there are methodologies used to reconstruct past climates. It doesn't just list techniques, rather it highlights their significance. First, we have the geological evidence from glaciers, or what we call glacial striations. So the direction and length of the scratches on rocks left by glaciers indicates the flow direction of the ice and distance traveled, which reveal the past extent of ice sheets and thus colder periods. The second one is the fossil pollen. So different plants thrive in different climates. So by analyzing pollen preserved in sediments layer, it shows the types of plants that grow in the past. So it indicates the past temperature and rainfall. Another one is CliMap. So CliMap means climate long-range investigation, mapping, and prediction. So this large-scale project combined various data sources to create detailed map of past climate conditions across different region and time periods, which provides a comprehensive view of past climate change. So these methods used together to provide a robust understanding of Earth's climatic history. So one of the powerful method is the ice cores or the ice core analysis. So it is extracted from glaciers and ice sheets, offer a unique window into past climates. So these cores contain annually layered ice, trapping tiny air bubbles and water molecules, reflecting the condition at the time of snowfall. So the analysis reveals past atmospheric gas concentrations like carbon dioxide and methane, and also its temperature variations based on the isotopic ratios within the water molecules, and other climate indicators such as volcanic ash or dust. So this multifaceted approach allows scientists to reconstruct past atmospheric compositions, temperatures, and other environmental changes over long time scales. So these ice sheets no accumulate layers of snow annually, trapping air bubbles and various substances within the ice. So each layer no, of the ice core represents a year, allowing scientists to build a chronological record stretching back hundreds of thousands of years in some cases. No? Now let's talk about another way no scientists study the past climates, which is called dendrochronology, or the study of tree rings. So trees no grow a new ring every year, and by looking at those rings, we can learn no, a lot about what the environment was like in the past. So first no, we look at the thickness of the rings. So when conditions are good, it means no, that enough rainfall and warm temperature. So the tree grows more no, and the ring is wider. But when the conditions are harsh no, or during drought or a cold year no, the tree grows less, which shows the ring is narrower. So the scientists also look for something called no, which is called frost rings. So these are the unusual marks in the ring structure that show the tree experience a sudden cold event no, like a frost or freeze, which it damaged no, its growth for that year. So in general no, the width of the tree rings is affected by temperature and moisture. So by studying the patterns like the wide, the narrow, and frost affected rings, we can actually piece together a climate timeline. No? So this is one of the ways we can learn what the climate was like hundreds or even thousands of years ago just by reading the trees. Then there are other methods also, no, like the sediments, pollen analysis, stalactites in caves, corals, no. So, ito muna ang mga methods na ginagamit uban sa mga scientists. So the graph shows no, the changes in Earth's average temperature over the time. So you can see no, the graph shows a long period of relatively stable temperature followed by a sharp increase in recent centuries. So the second graph no, shows that even within the period of warming, there are year-to-year fluctuations, but the overall trend is still upward. So both graphs no, together illustrate the significant warming trend of recent times. So this image no, shows a map of the Earth for about 18,000 years ago during the last ice age. So as you can see no, the arrow in the Bering Strait, so it indicates that this area, which is now underwater, was dry land and at that time. So it forms a land bridge between Siberia and Alaska. So the average temperatures in Greenland were for about 10 degrees Celsius lower than present, and the sea levels were about 120 meters lower. So exposing vast areas of land that are now submerged, no? So this map highlights the significantly different geography of the last ice age compared to today. Now let's talk about the causes of climate change. So climate change is a complex issue driven by both external and internal factors. So externally, changes in incoming solar radiation, alterations in atmospheric compositions like increase in greenhouse gases, and modifications to Earth's surface, which is the affecting albedo. So internally, no, it shifts in ocean and air circulation patterns, distribution, or distribute energy. So further influencing global temperatures, no. So understanding these interacting factors, no, is the key to addressing the challenges of climate change. So this image, no, or this illustration is the ocean's role in rapid climate change by showing global ocean currents. So as what you can see in the screen, so there is a warm salty water moves along the surface, which is shown in orange or red, no, arrows. Then eventually cooling and sinking, which indicated by the blue arrows, no. So this deep cold salty current then circulates and eventually rising again to become warm surface water. So the global conveyor belt system significantly influences the heat distribution, no, across the planet, and it plays a vital role in regulating Earth's climate. So the changes in this system, such as those caused by melting ice caps, altering salinity, can significantly impact global temperatures and weather patterns. So, as we all know, that climate change is driven by both natural and human cause factors. So, by understanding the contributors, no, of each is crucial for developing effective strategies to mitigate its effects. So, the first, the climate change, no, is influenced by several natural events, no. So these include feedback mechanisms within the Earth system, then followed by the theory of plate tectonics, which affects land masses on the ocean currents. Then next one is the Milankovitch cycles, or what we call the variations in Earth's orbit. The next one is changes in solar output. And lastly, the presence of atmospheric particles which influence reflectivity. So these natural factors now have caused climate fluctuations throughout the Earth's history. So the first factor that caused the climate change is the feedback mechanisms. So it is crucial, no, in understanding nature climate change. So we have here the two feedbacks, no, which is the positive and negative. So first is positive feedback mechanisms such as the water vapor, greenhouse effect, and snow albedo feedback. So it amplify warming trends, no. Then while increased heating is reinforced by other processes. So in contrast, negative feedback mechanisms, no, like the infrared radiation and chemical weathering feedback, weaken the interactions among climate variables, counteracting warming. So these opposing forces interact to create the complex and dynamic climate system we observe. So the image you can see now on the screen depicts how surface albedo affects surface warming and contributes to climate change. So albedo is the reflectivity of a surface. So first we have the high albedo, which is shown no, in the illustration A. So surfaces like snow and ice, so it reflects most sunlight, no, which result in low absorption and gradual warming. So as what you can see, no, it reflects anang mga orange nga strings diha. Then second one is low albedo, which is the illustration B. So darker surfaces like forest and soil, so it absorb more sunlight, no, which leads to increased warming. Then lastly, the very low albedo, which is shown in the illustration C. No, it is the lowest albedo, such as dark soil or asphalt. So it absorbs most sunlight, no, which cause enhanced warming. So the decrease in albedo, no, primarily due to the melting ice and deforestation, which leads to a positive feedback loop. So more sunlight now is absorbed, which cause further warming. So which in turn melts more ice and accelerates the warming process, contributing significantly to climate change. Next is the theory of plate tectonics. So as the continents move, ocean circulation changes, latitude changes, then volcanic activity, venting carbon dioxide, then mountain interaction with airflow and ocean currents. So the image shows the movement of the continents over 150 million years. So as what you can see on the screen, there are two illustration, which is the A and B. So the A depicts land masses approximately for about 150 million years ago. And the illustration B, it shows their current positions. So the arrows there, as what you can see, na siya yung mga arrows. So the arrows there indicate the relative direction of continental drift. So this movement affects ocean currents and wind patterns, which influence climate over long time scales. So as described in the theory of plate tectonics. Next is the Milankovitch theory. So it is developed by Milutin Milankovitch. So he proposes that variations in Earth's orbit influence climate change. So these variations include changes in eccentricity, precision, and obliquity. So orbital eccentricity refers to the shape of the Earth's orbit around the Sun. So it varies from nearly circular to elliptical over approximately 100,000 years. So a more elliptical orbit means Earth receives varying amounts of solar radiation throughout the year. So it influences climate patterns and it contributes to long-term climate change. Next is the precession. So precession is the Earth's slow wobble on its axis, like a spinning top. So as what you can see in the illustration A, this wobble takes about 11,000 years to complete one cycle. And as shown in B and C, this changes the timing of seasons relative to Earth's position in its orbit. So this affects the distribution of solar radiation and contributes to long-term climate variation. Next is the obliquity of the Milankovitch theory. So obliquity refers to the tilt of the Earth's axis. So we all know that the Earth is tilted for about 23.5 degrees. So varies between approximately 22 degrees and 24.5 degrees. But the current tilt of the Earth is 23.5 degrees. For over a cycle of about 41,000 years. So the changes in the tilt affect the intensity of seasons, which means a greater tilt leads to more extreme seasons, which is the hotter summers and colder winters. While a smaller tilt, it results in milder seasons. So these variations in solar radiation distribution influence long-term climate patterns. So the combined effects of those three cycles cause variations in the amount and distribution of solar radiation received by Earth, which leads to a long-term climate fluctuations such as ice ages and interglacial periods. Next is the solar output. So the variations in sunspot activity over approximately 11-year cycle cause slight changes in the sun's energy output. So when more sunspot means slightly more solar radiation reaching the Earth, which lead to a small warming effect. So this solar variability is a natural factor influencing Earth's climate, but its impact is minor lang siya compared to the significant warming caused by human-induced greenhouse gas emissions. So the scientists carefully consider solar variations when studying climate change, but these variations alone cannot explain the rapid warming observed in recent decades. So the last one is the atmospheric particles. So it is also known as the atmospheric aerosols or particulates. So it is a tiny solid or liquid substances suspended in the air. So it is a particles of ash and dust are ejected into the atmosphere and water vapor, making visible sulfuric acid particles, which is makaform siya og thick nga haze. So these particles can significantly impact air quality, visibility, and also to human health and climate. So both directly through light scattering and annihilation, and also indirectly by affecting cloud formation and chemical reactions in the atmosphere. So the 1991 Mount Pinatubo eruption released vast quantities of sulfur dioxide, ash, and dust into the atmosphere. So you can see it in the picture or the illustration. So it illustrates the significant impact of volcanic induced atmospheric particles on global temperature, which is nakakause siya og measurable short-term cooling effect. So this graph depicts the short-term cooling effect of the 1991 Mount Pinatubo eruption. So it shows a significant temperature drop of approximately 0.3 degrees Celsius in 1992. So as what you can see in the graph, makita gini mo siya nga ni ubos gyud ang temperature. So before a gradual recovery in the following years, this illustrates how volcanic aerosols impact global climate. Now there are other factors that contributes to climate change. The aerosols injected into the lower atmosphere, then the greenhouse gases, and lastly the land use changes. So first is the atmospheric aerosol. So it is a tiny solid or liquid particles which is ang sources niya from factories and vehicles. So it affect climate through direct and indirect mechanisms. So as what you can see in the screen, naana siya direct effect and indirect effect. So sa direct effect, they absorb and scatter incoming solar radiation, which reduce the amount of sunlight reaching the Earth's surface. While the indirect effect, they act as a cloud condensation nuclei, which leads to more numerous but smaller cloud droplets. So these smaller droplets make clouds brighter and more reflective, which increase the amount of sunlight nga i-reflect back into the space, and it can cause a cooling effect. So therefore, atmospheric aerosols have a significant influence on Earth's radiative balance and overall climate. Next is the greenhouse effect. So the sunlight reaches the Earth's surface, where some is absorbed and warms the planet. So greenhouse gases such as carbon dioxide, methane, ozone, nitrous oxide, and water vapor in the atmosphere. So it traps some of the heat that would otherwise radiate back into space. So human activities such as burning fossil fuels and agriculture, so mo na siyang makapa-increase sa concentration of these gases, which enhance the greenhouse effect and lead to global warming. So this diagram or this illustration is shows how sunlight is absorbed at the surface and it reflected back into the space by the atmosphere, and how greenhouse gases trap the heat from the sun, which is it causes a temperature increase. The last one is the land use changes. So the screen, as what you can see, it displays 4 examples of land use changes which impacts the environment. So first, they have the deforestation, which is all about clearing the forest, then agricultural expansion, intensive farming, then desertification and abandoned farming. So these changes significantly affect biodiversity, soil health, and contribute to climate change. So now we are going to talk about the global warming. So as we all know that global warming is a significant aspect of climate change. Now take a look at the screen. So we are going to talk about the image. So as what you can see, the image compares temperature increase model. So the left graph, which is the A or the graph A, shows temperature anomaly predictions based only on natural factors. So the observed temperature fluctuates around the prediction, and it indicates a relatively stable trend while the right graph or the illustration B, the natural and human forcing agents, no, it incorporates both natural and human factors. So here, no, the observed temperature significantly deviates from the model prediction, which shows, no, a marked upward trend, which highlights the substantial contribution of human activities to the observed global warming. So the difference between the two graphs, no, clearly demonstrates the impact of human caused factors on rising global temperature. So this graph, no, shows how much Earth's average temperature might rise by 2100s. So the black line, no, shows past temperatures, while the colored lines shows different possible future temperatures. So possible pa lang because napamanta sa 2020, napata sa 2025. And that future temperatures, no, is na siya sa mga 2050 to 2100. So the higher the pollution, no, the more the temperature will rise. So depende na siya on how much pollution, no, we create. So now, no, let's take a look, or let's look forward to the possibilities, no, the consequences of climate change. So the image, no, shows projected changes in global temperature. So as what you can see, no, the map on the left shows a possible temperature increase by year 2081 to 2100s. So with most areas, no, showing significant warming, which indicated, no, sa mga kanang red colors. So makita ninyo na siya kanang red colors diha. So the map on the right, no, shows temperature changes between 2001 to 2006. So illustrating a less extreme but still noticeable warming trend for many regions. So both maps, no, illustrate how climate change could lead to significantly warmer temperatures across the globe. So with some areas, no, experiencing much and more intense, no, warming than others. So by that time, no, so if we will not make a significant actions to reduce or to mitigate climate change, no, of course the future generations will undoubtedly suffer the consequences. Now let's proceed to the effects of climate change. So climate change, no, devastating effects are multifaceted. So melting Arctic sea ice, which is clearly shown, no, in the image on the polar region, no, above. So it dramatically impacts polar ecosystems and directly contributes to rising the sea levels, which is threatening, no, to coastal communities. Of course they are in danger, but simultaneously, no, alter the precipitation patterns, no, which is illustrated in the map with green, no, which represents the green one represents increases and the brown is represents decreases. Then it disrupt also the ecosystems globally, no, which cause both intense droughts and floods. So these changes, no, coupled with rising temperatures that leads to widespread habitat shifts and biodiversity loss, which creates a cascade of interconnected problems demanding urgent actions. Now let's talk about the efforts they are trying to mitigate, no, the climate change. So first is the geoengineering. So it uses technology no to directly manipulate the Earth's climate. It offers a rapid cooling no but posing significant risk no and ethical concerns. The other one is diplomatic efforts no. They rely on international cooperation and policy changes to reduce emissions and support adaptation, which is facing challenges no, of global consensus and political will. Now let's proceed to the final note of the climate change. So the final note no makes it says here, reducing greenhouse gas emissions and pollutants slows global warming, decreases haze and smog, and improves human health, providing significant benefits even if future warming is less severe than predicted. So the final note makes a really important point no. It's easy to think about climate change as something no that will only be a problem far off in the future. So we might worry about what the world will be like for our children or even our grandchildren, but it's harder not to connect it to our daily lives. So this note no changes that, and it says no that cleaning up the air by reducing the things that cause global warming also makes the air cleaner right now. So that means no less smog and haze, which means people get sick of when less smog and haze, it means people get sick less often, and children can breathe easier, and older people have fewer breathing problems. So it is not just about stopping a big problem way down the road no, but it's about making life better for everyone today. Even if the future no is not as bad as we fear or we earlier no, there are predictions no, we still get all these good things from cleaning up our air. So it's a win-win situation no? We help the planet and we help ourselves at the same time. So that's a powerful reason to take action on climate change. So that's all now for our discussion about the Earth's changing climate. So thank you for listening, and I hope you learned a lot from this topic and you act no and help our planet.